Please welcome Colonel Andrew Cap.
Good afternoon. I want to thank the organizers for inviting me to speak with you today. I'm the Director of Research at the Army Institute of Surgical Research in San Antonio. We've spent the past 20 years or so working on improving combat casualty care, and some of our work in conjunction with our colleagues DARPA and other academic and industry colleagues have led to the lowest battlefield mortality in history. And so we're very happy about that. But what I'm going to talk to you about today is the need to improve. We actually need transformational change in combat casualty care if we are going to meet the challenges of the future. If you've been watching the news, you know everybody has drones these days, and the battlefield that we're going to face in the future is going to be much more complicated and much more lethal. So we can't rest on our laurels. We have to improve. Advancing. There we go. Okay, I have no relevant disclosures. I'm a fully labeled, bar-coded, general issue Army officer with no financial conflicts of interest. Okay, so although we've made a lot of improvements in combat casualty care over the last 20 years, progress in trauma care generally has been slow. And I think we have problems that are conceptual in nature. Hemostatic bandages sound great, but the idea of putting something on cotton gauze to accelerate clotting is a 5,000-year-old idea. Tourniquets, 200 BC. Pre-hospital battlefield transfusion sounds really great. First, performed on an extensive scale in World War I. Freeze-dried plasma, low-titer whole blood, new products for us these days, World War II, and even tranexamic acid is a product of the 1960s. Meanwhile, there's been change in other areas of science and technology, as you all know. Many of us in the room probably remember using a rotary phone like that one. We now have iPhones. We went from chest x-rays to functional MRI, giving us not only structure but function at the same time. Unprecedented. Simple toxic chemotherapy being replaced by genetically engineered cancer-hunting cells. Fantastic. Where's the transformational change in trauma care? So we've spent 20 years making marginal improvements to existing technologies, basically relearning what we had forgotten in prior conflicts, and we got ourselves to the point of diminishing returns. And we need new pioneering engineering and science work to get us onto a new technology curve to meet the challenges of the multi-domain operating environment and large-scale combat operations. So at the ISR, where I work, we have completely reorganized ourselves. And so it starts with organizational change to really focus the teams on delivering what we need. So we've focused on the fundamental pathophysiologic problems to try to really get at the possibility of moving to conceptually new technologies that will improve care on the battlefield. So you can see what our 5 pillars are here. We know that blood resuscitation is important, but we need to treat the metabolic pathways affected by shock. We need to control hemorrhage, yes, but understand that the blood vessels are dynamic players in the response to injury. And there are opportunities to improve their function, prevent tissue edema and microvascular thrombosis that lead to organ dysfunction. If you have organ dysfunction, well, then we need to harness the best of biomedical engineering to develop better organ function support technologies. We need to go beyond stuffing Curlex gauze into a wound and wrapping it in ACE wrap on the battlefield as wound care, and put tools in the hands of medics that prevent wound infection and wound progression. And we definitely need better pain management on the battlefield. We need conceptual as well as organizational change. You can't think of blood as just a hydraulic fluid that flows through a bunch of pipes. Again, that dynamic relationship between blood and the vasculature is really describes an organ system in function. And in a complex system, there are often many points of failure. And so those need to be studied, and we need to find solutions to target those points of failure and improve outcomes, as you can see depicted here. So just a couple of things I'll sort of tease you with, we've been working on at the ISR. In the field of shock resuscitation, we've built on recent advances in our understanding of the body's adaptation to hypoxia. and basically are working on ways to accelerate that adaptation to enhance the efficacy of resuscitation. Similarly, we're targeting enzymatic and signaling pathways that lead to hemovascular dysfunction and that edema and thrombosis and organ failure I was talking about. We think that we're on the right track, but there's lots more to be done in this area. So with that, I want to thank you for your attention, thank the organizers for inviting me. I think our colleagues at DARPA are doing great things that you'll hear about, and I look forward to working with them and with you on solving these important problems.